This is 8 in 5, lesson 8, graphs of simple nonlinear functions. This is going to be hopefully a very quick lesson. It is just 3 slides, and it's really a review, again, of everything that we've done so far. And in fact, the summary of this lesson has been summarized multiple times in other lessons by me in 8 in 4 and 8 in 5. So hopefully, because it's review, it'll be short. Okay, so let's move on to the slides, our sketch pad, as I like to call it, and let's get going with some learning today. Okay, so I'm just going to give you the lesson summary, and this should sound really familiar. And the whole idea of this lesson is to identify whether these functions that we're looking at are nonlinear. Whether they are nonlinear. We've talked about linear functions, and we've talked about ways to identify whether they're not linear. And remember, one way that we've already learned if a function is linear or nonlinear is to look at the average rates of change using a table of values. So this is pink, and so I've made this table here pink to match up with the pink rule. And the pink rule basically says we find delta y over delta x between these 2 points, these 2 points, and these 2 points. This should sound just like the last lesson we did. And you see whether or not it's constant. And if these changes, delta y over delta x, y2 minus y1 over x2 minus yx1, if those things change, then we are not linear. So let's take a look at that. Let's just take a quick look at our delta y and delta x. Let's look between these two. Let's go. Well, our delta y is 2 minus 1 over 1 minus 0. And so our rate of change here is 1 over 1. So that's a 1. Now let's look at our rate of change between the next 2 points. Well, we have 5 minus 2 over 2 minus 1. And that's 3 over 1, or 3. So we already have a difference in our slopes between these 2 points and these 2 points, which is the same. You can look at it and you can say, well, this graph here represents these points. I intentionally graphed these points here. And you can see that this slope here is, this is our slope of 1 between these 2 points. But then between 1, 2, and 2, 5, we have this steeper slope. It goes like this. And so you can see that this is not linear. So here, by test number 1, it's not linear because our slopes change. Our slopes change. And number 2, the 2 rule right here in orange, another way to examine the graph is to examine the graph of the function. If all the points are not on a line, it's not linear. Well, you can see here that these points are not all on the same line. If I try and put these 2 on a line, it's not linear. But if I try and put these 2 on a line, I can't. The other ones don't fit. There's no line I can draw that fits all 4 points. So it's clearly not linear. It's not linear because not all points are on a line. So that's rule number 2. This was rule number 1. And rule number 3 says you cannot describe the data with y equals mx plus b. If you can do this, then it's linear. But if it can't, then it's not linear. Well, we know for 2 reasons that it can't be described by y equals mx plus b. The first reason is right here. It's because we have multiple m values. Well, if I have an m value, a slope of 1 here and a slope of 3 here, we can't use y equals mx plus b because what will we put here, a 1 or a 3? We can't put them both. So it clearly cannot be described by y equals mx plus b. And the second reason is I can give you the equation that gives you these points. And the equation is y equals x squared plus 1. So if you plug a 0 in for x, you get a 1. If you plug a 1 in for x, you get a 2. A 2 in for x, you'll get a 5. And a negative 1 in for x, you'll get a 2. So here's the function that describes those points. And you can see, because we have an exponent of 2 here, and we learned this long ago, that because we have exponent of 2, it can't be linear. Can't be linear. So if it can be written with a y equals x squared plus 1, it clearly can't be written as a y equals mx without a squared plus b. So those are 3 ways that we can identify a nonlinear function. Okay, so we're going to give you 2 examples, and then we're going to be done with this. Let's happy cat this, because these are 3 great rules, 3 great ways to know if something is not linear, or if it's linear, because if these slopes were all the same, it would have been linear. If this would have lied on a straight line, all these points, then it would be linear. Or if it was described as y equals mx plus b, it would be linear. But notice, any one of these tests can tell you that it's not linear. But we did it all 3 ways, just for fun. Now let's do our homework help, and you're going to get this question: is y equals 1 over x minus 2 linear? And I want you to prove it 2 ways. 1, I want you to chart the data, x and y. I want you to chart it and use at least 4 ordered pairs. Notice you can't use a 2. Because if you use a 2, you'll get an undefined. You can't have a 0 on the bottom. So we can't use 2. So maybe some good points would be like 0, 1, 3, and 4. And then I want you to graph it, and then also prove with the graph whether it's linear or not linear. Okay, so I'll let you do that. This is homework help. And I want you to pause and try. Pause and try. And while you pause, I'm going to make this graph over here for you. Whoops. Okay, so I assume you've tried this. And now let's see. Well, if I plug a 0 in, 1 over 0 minus 2, well, that equals negative 1/2. 1 over 1 minus 2 equals 1 over negative 1 equals negative 1. So this is negative 1. 3, let's see. 1 over 3 minus 2 equals 1 over 1. That's 1. And then 1 over 4 minus 2 equals 1/2. Yeah, 1/2. So now what we have to do is we have our data. Let me delete this real quick. And now we have to find our delta y. Here, let's do this in a different color just so it's really clear. So now we're going to find delta y over delta x. And we're going to see if those change. Uh-oh, negatives. I hate that. So negative 1 minus negative 1/2 over negative 1 minus 1. Well, this is negative 1 plus 1/2 over negative 2. So that's negative 1/2 over negative 2 equals 1/2 over 2, which is equal to 1/4, if you do your math on that. That's ugly. Well, let's do this next one. This next math problem is going to be a little bit easier. I'm going to do it in a different color just so when we run on top of each other, you'll see it. 1 minus negative 1 over 3 minus 1. Well, that's 1 plus 1, which is 2 over 2. So that's a 1. So we know that because these are different, this is not linear. It cannot be linear. So we don't even need to do any more math. We see that the slopes are changing between 2 points. Now let's go ahead and graph this data just so we can see it more clearly. So this will be -1, -2, -1, sorry, 1, 2, 3, 4. So we've proved it. We've proved it. We've done number one. Number one, check. You know, happy cat. We've proved that. Now number two, we're going to have to show it graphically, and we're going to see if we can just see it with our eye. So 0, -1/2 is here. Let's make these points in a bright pink. 0, -1/2 is right here. 1, -1 is right here. 3, 1, oh yeah, this is easy. 3, 1 is right here. And then 4, 1/2 is right here. Whoa, this is crazy looking graph. Look at that. But there is definitely no line you can draw that puts everything on the same line if you just kind of look at it. 4, 1/2. Yeah, there's clearly no straight line here that connects every single point. Okay, so hopefully you can see that, and we have proved it now in 2 different ways. No line can contain all 4 points. So it's not linear. And again, we've done this before, right? This isn't anything new. This is stuff we've done from past lessons. Woohoo. Okay, so let's move on and let's just do one other homework help. And so is this data linear? Prove it 2 ways. This should be an easier problem. So I want you to pause and try. Okay. First, the first way I'm going to prove this, hopefully you've done it, is graphically. Graphically. There is no line that contains all 4 points. So it's not linear. Okay, right? Let's just see that. Let's just see it, right? This line doesn't contain all 4 points. This line doesn't contain all 4. In fact, I don't think you can put 3 lines. You can't even put 3 lines on, or 3 points on any given line. So graphically, it's not linear. Now we have to do a little bit of work, and so we're going to use our table method here, and we're going to put our X's and our Y's down, and let's just flip this over and do it in green. Switch up the color. So we have 1/2, 4. Why did I make it a negative, Mr. Lipscomb? Why did you do that? 1/2, 4, 1, 2, 3, 1, and 6, 1/2. Well, let's find the slope between these easy ones first. 2 minus 1 over 3, sorry, 1 minus 2, y2 minus y1 over 3 minus 1. So that's -1 over 2. So that's a -1/2. So that's the slope between here and here. And now let's do the top one. 2 minus 4 over 1 minus 1/2. Well, I don't like fractions, but that's what we're stuck with here. -2, and so that's -2 over 1/2. Well, -2 over 1/2, I'm going to do the math down here. -2, I'm going to remind us how we do this, divided by 1/2. I have to put both things in fractions. So that's -2 over 1 divided by 1 over 2. And now I have to invert my second one, -2, and make it a multiplication problem. And so that equals -4. So that's -4. So my slopes are different. Different slopes between points, between pairs of points on same line, on same curve, means it's not linear. And that makes sense, right? Because here's the first slope I calculated of -0.5, and here's the second slope I calculated of -4. And those clearly aren't on the same line. They can't be. Different slopes mean not linear. So we're done with this guy. Happy cat for the graph, happy cat for this, and happy cat for remembering how to do your fractional calculations, which can be ugly sometimes. And I'm just going to leave you with this lesson. Over and over on the homework, all you're going to be doing is being given graphs and seeing if the data is linear, or being given a function like we did on this problem here. You'll be given a function, and you'll need to make a chart, and then you'll need to calculate whether it's linear, and then maybe make a graph and then check whether it's linear. And that's the whole gist of this lesson. The whole gist of this lesson. And again, it's really just review. And we've been doing a lot of building on just what we've been doing all year, which is great. You're synthesizing, synthesizing information, looking at problems a little bit differently, really consolidating that math knowledge, and it gets real exciting because you guys are doing awesome this year, learning some solid mathematical foundations. Algebra is the foundation of all math, and just really relish in the fact that you're getting stronger at that, and you're going to have a great rest of 8th grade and into high school year. So give yourselves a hand. Uh-oh. Our happy clap isn't working. I'm not sure why. We'll just stop it here. No more technical difficulties. See you with 8 and 5 lesson 9 next. Bye.